Hello class. This week we're going to dig a little deeper into methods. We're going to do something called method overloading, how we can have methods with different signatures but the same name. We're going to look at some error checking for parameters. We're going to see how we can use the scanner in methods and why we should not be creating multiple scanners for the same input stream. We're going to look at references in methods, meaning arrays and objects. And then we're going to dig into some memory regions. We're going to look at how Java separates different areas of memory to be used for different items. And we're going to kind of do this through some examples. So first, I wanted to take a look at how Java breaks up memory into different areas. So just looking at this chart here real quick, we have four main areas. We have the code section. And the code section is, as it says, the code where the compiled Java code is stored when it is built by the compiler. We have a static area, and that's where our static variables are stored, meaning static variables are declared once. They live for the life of the program, and they do not change. We have our stack. And the stack can be thought of a stack of papers on a desk where you put things on and you take things off. So as we call different methods and do different things, we put items on the stack, we put variables on the stack, we pull them off when the methods terminate. And then we have the heap, which is the biggest area of memory. The heap is where we have our objects and our arrays and anything that is created with the new constructor. And we'll see how that all works as well. So let's start out with an example. I have gone ahead and opened up a version of our testing utility here. I opened up in full screen, so we have a little more room to work in. And we're going to create a student class. So I'm going to get rid of this lab program, but first I need to create a new one. I'm going to call it student.java. And we'll open that one up. And we will delete this other one, or at least close it down. We don't need it. We're going to work in student.java. So we're creating a program. We're going to create some code. So this code, when it's compiled, will get stored in the code region of our memory. It is a read-only area, meaning once the code is compiled, it is stored in that area of memory and cannot be modified, which is good because you don't want your code modified while it's running. That's usually a pretty bad thing and can be exploited for bad things. It can be exploited for malware and viruses and all that stuff. So once it's compiled, it's read-only and cannot be touched. So let's go ahead and start working on a program. And this way we can kind of demonstrate a few more things here along the way. So we're going to create our program. We're going to call it public class student. And that is our program. Note that the class matches the file name, which is always good. We're going to create some instance variables, and we'll call them instance variables. And let's see, what would any student class have? A student should have a name. A student will have an ID number. And a student will have, let's have an age. Let's have another integer. Private int age. So our student has these three properties: a name, an ID number, and age. We'll need a constructor. So let's build our constructor. Name and int age. I am specifically not going to use an ID number when I use the constructor at this time. I'll demonstrate why in a minute, but for now we're just going to use these two items to create a new student. So when we go to create a new object, we need to provide a name and an age to create our student. So since our parameters into the constructor have the same variable name as our instance variables, it's wise to use the this construct so we can properly assign the values. So this dot name equals name, and this dot ID, age equals age. So this is telling us that this name here is this name here, and this way we can assign it and create our object. Now, this is great, and we have our constructor, and this will work fine for us, but what are we going to do about the ID? Got to equal something. We have to assign everybody an ID number when they're created. Well, I think what we want to do is we're going to create a static variable. And we're going to create, it's called a class variable. I think we've talked about that before. We're going to create a class variable, and we're going to call it student count. Private static. This is where the static comes in now. Student count equals 0. So when we first run our program and it defines this new variable, student count, this will be created over in our static area. So our static area gets our program's static variables. So we have our instance here, or I'm sorry, a class variable stored here in that area of memory, and that's going to contain our student count equals 0. So our class variable will be available to any object that is created of this student type. So it lives and it is common for all objects. So we want to assign the ID number, and we'll just keep it simple. We'll give it to the student count. So your ID number is equal to the number of students that were created. And that's kind of how it works here at Suffolk as well. Every student gets the next available ID number on the list, so you can basically count how many students there were since we started, more or less. It's not 100% accurate. So based on your own ID number, it's an 8-digit number, starts with a 0, it's 0135 something, or 0136 something, or in my case 0039 something. So it's just an increasing number, and that's how we're going to do it here. So we're going to assign it to student count. So we don't want to have a student with a ID of 0. That's kind of silly. So we'll increase the student count before we assign the ID number to the student. So now we have whenever we have our student created, we assign the name, we assign the age, we increase the number of students in the counter, and then we assign that count to the ID number. So we have our static variable, we have our instance variables, we have our constructor. What we need now, among other things, we need a main program. So let's create a main program. Public, or main method, sorry. Static void main, string, or typical signature for the main. And we want to create a student. Let's call it student for the data type. S1 equals new student. And we'll give it a name, and we'll give it an age. So I'm an older student, but that's okay. I can still come here. And we can have another student. S2 equals new student. And we'll use Alice. Alice is 19. And let's create one more student. So we have 3. Student. And we'll have Bob, good old Bob at 20. All right, so we have our 3 students, and we've created them. So my ID number will be 1, Alice will be 2, Bob will be 3. All of these objects created now are living on the heap. So all these are living on the heap, and they all have memory references going back to our stack. So whenever we create a new object, it's created on the heap, the memory reference itself is stored. So we're going to be doing a little bit of interrogation of the objects. We need to keep that in mind, that it's stored over here by memory location, not by direct value. If we create a regular variable, let's just call it, let's create another variable here. Public, or we can just do int student counter. Oh, that's a bad choice. Count equals 0, and for each one we create, we'll do count plus plus. I know it's kind of redundant, but humor me on this. So we have our integer variable count that we start out at 0. That variable is stored here on the stack. Every time it is updated, that value is directly updated on the stack, and that continues to increase in value as we run our program. In a comparison, each of these student objects, S1, S2, and S3, while they are built in the heap and stored in the heap, a memory reference passes from the stack to the heap. So we know how to get from S1, instead of looking in the stack for the data, we look into the heap for the data based on the memory location that is stored here. So let's take a look at that. So if I go ahead, and let's say I just want to have our print, and I want to print out everything about Bob. And I just do S3 to print out all of Bob's information. And if I run this, it's going to print no output, which is not what I was expecting. Why did it not print any output? It should have printed the memory location of S3. So, okay, so that's just a Zybooks thing. So what will happen in Java, this S3 has a memory location, and that memory location is what is being stored on the stack. And that is what I wanted to demonstrate, but Zybooks is not playing nice. So we'll skip past that for now. And instead, if we do want to print out somebody's information, we need a method inside of the class to do so. So let's create a method inside the class and be able to do that. So let's create a method, and let's call it public void, just how about display info? That's good. And it's just going to display the information from this particular student, and we can do a system.out.println of name, and we'll add in the name. And then we can add in age, and we can add in the age itself now, and then we'll add in ID. There. So that little string will print out our information about the student. So we'll come back to our main piece of the program, and we can do an s1.display info. So when I call s1.display info, it's going to create a new frame on the stack, a new list of memory locations that are going to be stored on the stack for anything that is declared in that method. Well, in our particular case, display info has no variables, but had I declared a variable in there, it would be displayed, it would be stored in the stack. When display info ends, meaning when this method returns and exits, any variable associated with that stack frame that was created by display info is removed. So this is how memory is allocated and deallocated. When a method is called, all variables are stored on the stack. When it is returned, all variables are removed from the stack. So let's just demonstrate this works. We'll do a little bit of a run here. And I'm still getting no output, so something is going on here. Let me take a look at this. Okay, so I was doing a little testing in the background here, and this seems to be a Zybooks artifact of not displaying output properly. So what we're going to do is we are going to split this Java class into two programs. So we're going to keep public class student as its own student.java, and then we're going to go back into our lab program.java, and I am going to copy the public static void main piece out of there, and I'm going to put it back into here, and we're going to have the lab program run, because I think this is how the lab emulator is built, and I think that's the issue here, because I just ran this whole sequence in another compiler and it worked just fine. So let's see if this makes a difference now. If I run lab program yeah, there we go. Okay. So now we have our display info displaying properly, calling our method display info, again, puts it on the stack when it's called, takes it off the stack when it's done. So let me go back, and one of the things I wanted to demonstrate earlier that didn't work is the printing of the object itself. So now you see when I print out S1 is a student object, it gives me this memory location. So it's telling me what kind of object it is, what kind of class it is, and it's telling me where that lives in the heap, in the memory location of the heap. Now this really doesn't mean anything to us, but this is the value that's stored on the stack. So whenever the S1 object is referenced, it knows to go look at this memory location so it can get to the variables that are part of our class, meaning the name, the age, and the ID. Okay, so we have the ability now to create objects, giving it a name and an age. What if we didn't know the age of the student? Let me just comment this in, put a comment here for us. This prints the memory location is the heap of the S1 object. And I'm going to comment this out because we don't need to see this right now. What if I wanted to create a new student? S4. But we don't know the student's age. Why am I doing that? That's silly. Student. And Charlie. And I don't know that person's age. So we're just going to put in no age. We'll leave it out. And if I run, Charlie is going to complain as I'm trying to call a constructor, which is a method, with the wrong signature string. So you can see I need to have a string and an integer. I'm only providing a string. So what we can do is we can create another constructor with just the name. And this is what is known as method overloading. It works for the constructor, it works for all methods. So I can assign, and I still want to do my student count piece. That's still very important. We're going to put that in. We need to give the student an ID. But what do we want to do about the age? We need to set it to something. We could set it to 0, I guess, as a placeholder, just so we know that the student needs an age if we see a 0 in there. Let's see how this looks now. So if we back to our lab program, and I want to do S4 display info, and I run, Charlie, his ID number is 4, which is correct, but the age is 0. So we want to fix that. We don't want to have it display 0. Maybe we want to display something else. And then if we could put a little smarter in here, if age, because we're using a instance variable, this is from the object itself. So when age is referenced, if age is equal to 0, maybe we want to do a different type of print. And I'm just going to copy most of this so I don't have to type it again. And line it up. And instead of age, we'll do age unknown. Else, if the age is known, we can print the correct age. So there, we just modified our program a little bit. If the age is 0, then we will print unknown. Otherwise, we will print the correct age. Let's try that. Age unknown, perfect. So we were able to overload a method, and we were able to create our object with either one parameter or two parameters. So you can create as many different methods as you'd like, provided that the method signature, which is these listed parameters here, is different. So I cannot create another method with just a string parameter. It will not allow that because I already have one. I can already have one with a string and an integer, so I cannot create a second one with just a string and an integer. But if I wanted to create something else with more parameters, I certainly can do that. Doesn't make sense in this example, but you can create as many methods as you want with the same name but different signatures. Okay, great. So, next thing we want to consider is error checking. If we have an age, we want to make sure it's a valid age. So, what if we tried to create a student? Let's create S5. Student S5 equals new student Diana, and age of -1. Again, not a valid age. And if I do an S5 display info and run my program, it certainly will take the age stored as -1, because that's what we tell it to do in the constructor. And then when we do our display, it displays the age of -1. So the display is working properly, the constructor is working properly, but does it really make sense to have an age of -1? So maybe we want to put some logic in here. Maybe we want to check this before we actually create it. If age less than 0, then what? Maybe we want to display a message. Age invalid, setting to 0. And then we can do age equals 0. Now you can see where the age, and it gets a little ambiguous here. Which age are we talking to about? Are we talking about the parameter age? Are we talking about this age, the one for the class or the object? So this is where it really helps to clarify things by using the this, or by using parameters that don't have the same name as the variables. So you can see how it gets pretty confusing pretty quickly. So we'll just build a little if statement that says if it's less than 0, we'll set it to 0, otherwise we set it to the age. And now if we run our program, Diana, age unknown, age unknown. That would be coming from the lab program. So we did not set the age properly here. Let's take a look at that and understand why. Actually, it did everything perfectly right when you think about it now. Take a look at our display. If age is equal to 0, then we print unknown. So maybe we want to adjust this somehow so that instead of equal to 0, is less than 0, it'll print the incorrect value. Let's try it now and see what we get. There, age 0, setting to 0, age 0. So shows you that when you make a small change to your code, you still have to test out every little piece that is affected by it. So we made a change to something that affected the age. We needed to test out this method here that is using age as a indicator to print a different message. So we have to be a little careful about that. So we have our way of checking for errors, making sure our parameters are correct, and if they are incorrect, we can print a message, we can take an action, and you can do this for any method and any parameter. Make sure your values are correct before proceeding. Otherwise, you could have some other unintended consequences later on down the line. Okay, let's create, let's take a look at a scanner now. Let's say we wanted to give the user the ability to enter the age instead of hard coding it like we have now. So we'll go back to our lab program, and we can do our student S6 equals new student. We'll call it Frank, and we want to be able to have the user enter an age. So we need to use a scanner. So, well, the rules for scanners are a little different. First, we need to create a scanner. And we'll create that here. Scanner, SCNR equals new scanner, system in. So this is a typical scanner where we're reading from the keyboard, and we want to make sure that we have only one reference to the scanner in our entire program. The reason why is when Java runs and you implement the scanner class, the scanner could read more information than it's needed and then process it internally as you use it. So it may read ahead. Think about a book. If you have a paragraph in a book and you tell the scanner to read from that book, it may read that first paragraph when you really only want to read that first word. And this is because input-output operations, which we'll see in the next section, are very slow relative to processing in memory. So going out to a disk to read something or waiting for to read something from a user input is slow compared to reading it in a memory location. So the scanner looks ahead, tries to read as much as it can, and processes it as needed by the program. So if it does that and you had created a second scanner, the second scanner could be reading from the second paragraph in that book, even though you really wanted to read the second word in that first paragraph. So we have to be a little careful of that. So the idea is you always declare one scanner per input stream, and this input stream in this case is system.in, and you take that scanner and pass it into the method in the constructor in this case. So we're going to create our scanner here. So I went ahead and I cleaned it up a little bit. I don't want to use the scanner as part of the constructor. That's going to cause all sorts of problems that we really don't need to deal with. So instead, let's create a new method. And I did that down here. I created this new method called getAge, which we're going to prompt the user to enter the age of the student, simple print statement, and we're going to return scnr.nextInt. So we're going to return our scanner.nextInt, and just to separate the two, I'm going to give it my p underscore syntax, just so we don't get confused here, that we're confusing this scanner with this scanner here on line 7. So if I run this code, no errors, which is good. So let's call our method here. So let's create a new variable, int student age equals 0, And we can do student age equals get age. Now what parameter do we want to pass in there? Well, we want to pass in our scanner. So we can do our input, and we get our input from the console. Let's do a quick run, make sure there's no errors, and there are, and it does not like what I just did, so let's take a look at that. Okay, so interrogating this error message is complaining at line 27. 27 is the method call of getAge. So it's not complaining about the method we created, it's complaining about how we access the method. And it's saying non-static variable scanner cannot be referenced from a static context. So let's see what that means. So we have our scanner defined here. We have our static method. And the issue here is that we accidentally, well, we meaning I, created the scanner not in the main method, but in the class itself. And we don't want that. We want to create it in the main method. So let's put that in there. Because now it has part of a static class, and that removes the static, non-static issue. Remember, static and non-static has to do with where the memory is stored, or we have it defined once, versus defined when used. So let's go back, and we have our age prompt. Let's see if it runs now. Great, it did. So if I run this now, we still have our complaint about the age invalid, and that's from Diana here. So might be a little more information we want to add to this so we know what student it was complaining about when we created our age. So let's put an age in here for the student. Let's put in -5. Let's see what happens. Name Diana, age 0, 5. So this is printing from S5. That's for Diana here. That is not this -5. So let's organize our code a little bit better. So we have our student age here. Let's create our Frank now. Student S6 equals new student Frank, oops, in quotes, Frank, and student age. Alternatively, we could have used, instead of student age, we could have put this method call directly in here instead. Either way is fine. So this should create Frank with an age of -6, but let's clean this up a little bit. Let's fix our display info to add a little more information here about the name. Let's do name plus age is invalid. This way we know who we're setting it for. So now if we come back to our main program, and we can do s6.displayInfo, we should hopefully get prompted to enter Frank's age. And here's our display error, first error for Diana, setting to 0 for the -1 age. If we now are asking for Frank, we can now put in, let's put on the -5 again. Frank age is invalid, setting to 0. So perfect, so that worked. So we were able to pass the scanner in to another method here and get the age. Let's further demonstrate that by creating another scanner, or another student, sorry. Student S7 equals new student, and let's actually prompt for the age, the name this time too. So we'll need to create a new string variable. Student name equals right. We're going to create a new student. We're going to pass in the name into the scanner instead. This needs to be capital S. So we can do a student name equals scanner dot next, and it's always good to prompt the user for input. Enter the student's name, enter the student's name, prompt them for the name, and then get it, and then create the student name, and then we can do get age scanner. The whole 9 yards right here in this last student 7. And let's take out this because we don't need it, and we'll do s7.display info. So if all goes well, pending any syntax errors, we'll prompt for the name in the main program, we'll prompt for the age in the method, and everything should be working. Enter the age of the student. It did not ask for the name. Enter the age. Oh, it's because I'm doing it up here for Diana already, or for Frank already. So let's fix that. Let's put it 4 for that. Now enter the student's name. All right, good. What's after F? G is name with G. Georgia. Enter the age, 12. And there we go. So now we can see, you can see how we can pass the scanner in as a parameter, so we read the right amount of information each time. So I did talk a bit about memory and how things are put onto the stack and removed from the stack. How do we know when to remove a memory object, or how do we know when to remove a data item? Well, whenever a variable is created internally, a reference count is allocated to that item, whether it's an object or a primitive type. So that reference count gets increased every time something accesses it, meaning another method or another reference to that object. So that reference count is increased. If we call a method and it puts another object, another frame on the stack, that reference count's increased. When that frame is removed, that reference count is set back to, or decreased. Eventually, the reference count will get to 0. When it gets to 0, it is eligible for what is called garbage collection. And what garbage collection in Java does is it goes in and removes variables that are no longer needed, meaning they have no more references. So if you have an object or a variable with no references, you can't get to it in memory. If you can't get to it in memory, it serves no purpose, and there's no point in holding on to that memory. It might as well be released so other programs can use it. So that's the whole idea behind garbage collection, is to make sure that memory is released when it's no longer used, and it gives the programmer more flexibility. And you almost feel like you have more memory than your system actually has, because you're using and releasing behind the scenes without even knowing it. So garbage collection is very important. It makes sure that you don't run out of memory. So that's a little bit about garbage collection. It's very interesting to read up on that. There's whole chapters and other books set aside specifically for garbage collection. But just basically to understand how it works is that it removes things that aren't used anymore. And it does it periodically. Okay, next up, and our final topic, even though this video is getting a little long, final topic is arrays, array references. So if we pass an array in, so remember, an array is an object, and objects are stored by memory location in the stack. If I pass in to a method an object or an array, it passes in the memory location. So now we have two references, one in the main program and one in the method, pointing to that same place in the heap. So if I make a change in a method to something that's pointing in the heap, since two things are pointing to the one same spot, both references are updated. So let me demonstrate that. And let's create a little method here. Public static void. We're not going to return anything in this one. We'll call it array test. And we're going to pass in an int array. Okay, so we'll set that up, and we'll pass in an int array. What we'll do is we'll define our int array here in our main program. And we'll just give it some simple values. We'll give it a name first. And we'll just give it 1, 2, 3, 4, 5. It's a very simple array. Five elements, numbered 1, 2, 3, 4, 5. Okay, so let's now build our method out, and we want to give it the parameters. We'll give it the int array. Oops. And what do we want to do in our loop, or our array here? Let's create a loop, and let's simply multiply the elements by 2, just to have some change. And so we can do a loop for int I equals 0, I less than p. Oh my god, I can't type. Array dot length and I plus plus. And we could do p underscore array index I equals p array index. Oh my gosh. Index I times 2. Very simple. Simple little array to calculate the element times 2 and restore it back into the array. Okay, we created our method. Let's give it a run. Before we do that, let's comment out some of this this other stuff here where we're using the scanner, because we don't really need that right now. I will post all this code later as a sample so we have it. So let me comment this out just for now, and we'll take a look at it again later. Okay, so if I run this now, I just want to make sure there's no errors in my method. And it didn't complain, so that's good. So we have our array, and let's, in our main program, we can create a loop. Int I equals 0, I is less than array, int array dot length, because that's what I called it up here, int array. I plus plus, and all we're going to do is system.out.println int, no quotes, int array I. So if I run this program the first time, oh, I gotta take care of that Diana thing, that's getting a little annoying. Fix that. Okay, so we printed our array out, 1, 2, 3, 4, 5, and great. Now, if I call our array test, and we give it the int array variable, and I run it again, well, we still have our same output. We have our initial output, initial output. And then we can print it a second time. And we can call it modified output after we did the array test, right? You'll see that the output is different. Even though we did not return any values. Our return value was void, so we did not return anything. But since we're passing in an object, we're passing in the memory location into the method. So the method then accesses the heap based from the stack frame. So we have in our main program, we have our int array. It has a memory address, and it is pointing to the heap where we have all the values of the array. When we call our method, it makes a copy of that memory address, and it has to access it. So it accesses the same location in the heap. And it updates the heap and updates the variables in the heap for our object, in this case the array, makes the modifications, and comes back to the main program. So you need to be careful when you're passing arrays into a method, because if you do modify an array or an object, it will update it for everywhere in the program. So you can kind of think of it as kind of like a global variable kind of thing. Just be very careful when you're passing in arrays into a method. Okay, so I think that's about it for today. It's a pretty long video, so hope this helps. I will post all this code into our sample code area so you can reference it, and I guess that's it for now. Have a good day. We'll see you in the next one.